material would be the cereal, the sugar, the milk, which gets poured into the bowl, and the older material would be the bowl itself. If you flip the cereal bowl over and you start pouring material on top of the cereal bowl, it slides off to the side. Well, that you could think of that as a dome, where the oldest material is in the center and the younger material is off to the sides. Here's a couple of pictures. Here's a dome. There's some upwarping here. Definitely you can see, you have an anticline here. And this material, some of the material is eroded away, and it leaves the oldest material in the center and the youngest is on the edge. Here is a basin or a syncline, and here, this would be the edge of the bowl on the outside. And so that would be the old stuff, and the youngest stuff would pile up in the middle. Michigan is a good example of a basin. This would be the edge of the cereal bowl, and all this material here is put into the cereal bowl. If you've gone up through the straits and up towards Sault Ste. Marie, you start cutting through, you see the road cuts. That's really the edge of the Michigan Basin. This is a link to some more information on the Michigan Basin, and we'll look at it in class also. A good example of a dome or some upwarping are the Black Hills of South Dakota, where Mount Rushmore is. These are mostly granite type of features here, and these are not normal or reverse faulted mountains. These were from an upwarping, and the softer material has eroded away, leaving the Black Hills. This next one we're going to take a look at fossils, what makes up a good fossil, and what index fossils are. And here's a little picture, little diagram of how we're going to do this. Fossils, really you need hard parts, bones, shells, teeth, etc. Rapid burial is important. If the critter's sitting out after it died, it can get eroded away, it can get eaten, and it can get scattered, and you would not have good fossils. But if you get rapid burial, like from a flood, stuff gets covered up very quickly. Mud pits, tar pits, the La Brea tar pits outside of LA is a good example of this. Things make good fossils, and fossils are in sedimentary rocks. As we know, you get into the igneous, it's magma or molten rock which has melted. And then again with the metamorphic rock, what ends up happening is that heat and pressure would destroy any fossils that would be in the rock layer. Index fossils we briefly touched on in class, but index fossils are used to relatively date different layers of rock. And what you look for in index fossils is easily recognizable. Everybody agrees that this is what it is. It's got to be widespread geographically and a relatively short lifespan. Now again, relatively short may end up being a few million years old. Your last couple of assignments in the computer lab, you did some relative dating using, you used some index fossils. The geologic time scale, many forms out there. You can see, we've looked at this. You looked at this with the, especially with the last activity you did in class, the relative time dating. And one thing I want to notice down here is this, what's called the Precambrian. And this Precambrian period covers about 88% of Earth's history. And the Earth is like 4.5 to 5 billion years old, and 88% of that time is Precambrian. When you guys looked at your football field activity and you saw most of the things were really put near the top or relatively recent geologically speaking. A couple things you might want to know: Paleozoic, the age of ancient life, and the Quaternary is the age in which we live in currently. A couple big extinctions, and the first one is the Paleozoic. When you think of extinction, you're wiping out species. Well, this one occurred at the end of the Paleozoic area, and all these marine critters, which the Earth was covered by a lot of sea at this time, died off. And this was due to cooling of the Earth. Most marine critters do like warmer water, and what ended up happening as you get these climatic changes or cooling, many of these critters died off. The big one everybody talks about, of course, is the dying off of the dinosaurs, the Mesozoic extinction, in which the dinosaurs died off. A meteorite hit the Earth, threw all this dust, ash, and other material into the atmosphere. Global cooling took place. What ended up happening, there's no more photosynthesis, so the animals that ate the grasses died off. Therefore, the meat eaters, the carnivores like T-Rex here, died off also. The best piece of evidence for this collision is when meteorites contain iridium, and there is a thin band of iridium found worldwide, what's called the Cretaceous Tertiary boundary, and this is the good evidence for that.